All right, here in lesson 1-4, we are going to be doing a couple things. We are going to first look at how we can evaluate trig functions of any angle, not just ones that are on the unit circle. We're going to look at finding reference angles and how your calculator, it might not be lying to you, but it might not be giving you the whole truth. And then how we can evaluate some different, say, triangles or trig things towards the end here. So first off, to evaluate trig functions of any angle, say we've got this kind of theorem or formula or something like that, where let theta be any angle in standard position with x, y a point on the terminal side. So again, x, y can be anywhere, any quadrant, any axis, anything like that. And then we have this r equals the square root of x squared plus y squared, not equal to 0. So basically that is telling you that it can't just be the point 0, 0. Okay, it can't be the origin point. If you wanted another way to look at this thing here, say this thing here, if you were to square both sides, you would essentially end up with just a different notated version of the Pythagorean theorem. It's just instead of a squared plus b squared equals c squared, we go x squared plus y squared equals r squared, where r is kind of this radius of whatever circle it is you're working with, or kind of what circle you would make given the point that you're working with. And then all we kind of do to find sine, cosine, tangent at a given point, not necessarily on the unit circle, we just redefine, instead of in terms of opposite, adjacent, hypotenuse, we define it in terms of x, y, and r, say, which are things that we can find. And now these things here are on your unit circle as well. They're, again, in that kind of top left area right below the sine, opposite, adjacent, and all those different things. So don't feel like you have to scribble these down at all. But again, this kind of opens the door to evaluating different angles, not just ones on the unit circle. So if we were to say let -3, -4 be a point on the terminal side of angle theta, so we kind of have that represented over here. So we're talking that angle right there, or I guess technically it could be this angle here. It doesn't necessarily specify which way, whether it's the positive angle, the negative angle. So it's going to have the same sine, cosine, tangent values anyway. And so what I would maybe do before we actually find sine, cosine, tangent is go and find that r value. Okay, so if we know x is -3, y is -4, then r is going to be the square root of -3 squared plus -4 squared, which the big thing to remember there, when you are squaring a negative, it still becomes a positive. So that's going to give us the square root of 9 plus 16 is square root of 25, which gets us 5. Now, one thing I did want to kind of mention here, within that like r value thing, say r is always positive. Okay, because you would always be squaring things here, you're always going to get positive values here, which will always give you a positive value inside that square root, which is going to always give you a positive r value. Okay, but then once we have r, we can basically plug in x, y, and r into these different formulas here. That sine is y over r, so that'd be -4 over 5. Cosine is x over r, so that'd be the -3 over 5. And then tangent would be opposite, or not opposite over adjacent, it'd be y over x, which would be -4 over -3, which our negatives could cancel, and we could get the positive version of that, so just 4/3. And again, like always, if you wanted to find cosecant, secant, cotangent, you could just flip your sine, cosine, tangent values. And in this case, it'd be pretty easy because they all ended up being whole numbers anyway, so we wouldn't have any kind of weird square roots that we'd have to rationalize or things like that. Okay. So that's how we evaluate trig functions at any angle, as long as we have the point that we're using to create that angle. Kind of our second thing for the day is what we call a reference angle. And so the definition of reference angle is let theta be an angle in standard position. Its reference angle is an acute angle denoted with that theta symbol with a little apostrophe thing, basically saying, okay, this angle here came from a different angle, theta, to begin with. Okay, but that is formed by the terminal side of theta and the x-axis. So it's always the angle between the original angle theta and the x-axis. Say the shortest trip to the x-axis. So if something was in quadrant 2, this angle here would be your reference angle because this would be your original one. If it was in quadrant 3, if this is your original one, or even if this angle here is your original one, your reference angle is still just this part right here, the angle from the terminal side to the x-axis. And then in quadrant 4, it would be this one right here. Okay. If you're wondering, well, where's quadrant 1 here? Quadrant 1, if your angle is in quadrant 1, say it's just going to be this part here, which a lot of times, I feel like more often we deal with positive angles more than negative angles. So usually in quadrant 1, your original angle is the same as your reference angle. A lot of times. Okay. Not always. Because if we were measuring this thing in the negative way, then this would not be true. But like I said, more often than not, we probably deal with positive angles than negative. And so usually in quadrant 1, the two are going to be the same. But then we just kind of review again where our reference angles are in quadrants 2, 3, 4, say in those different scenarios. Say the one thing I wanted to mention here, did we get it? Yep, and so I kind of skipped over. Reference angles are always going to be positive, okay? Even if you're dealing with negative angles to begin with, so your reference angle is going to be a positive value. So if we look at a couple of kind of scenarios here, so if we have an original angle of negative 210 degrees, that would be something, say that looks roughly like this here, and we're measuring, say, in that kind of clockwise rotation. And so if negative 210 is here, if we went this way, then this like half circle is going to be negative 180 degrees. And this would be negative 210. And so ultimately we're looking for this little angle right there going from our terminal side to the x-axis. And some of you might be able to just look at that and see, okay, what's the difference between negative 180 and negative 210? If it helps you to actually write out negative 180 minus negative 210, which ultimately would be negative 180 plus 210, and get you 30 degrees. Like I said, some of you might be able to just look at that and see, okay, the gap between negative 180 and negative 210 is 30 degrees. So, and again, it should be a positive even though we are dealing with negative angles. Okay. If they give us something in radians, say we got a couple here, one where we don't have pi involved and then another one where we do, we can look at maybe how we'd handle those a little bit differently. If there is not pi in your radian degree, what you could do is take those like pi measurements. So like 90 degrees is pi over 2 in radians. You could take 3.14 divided by 2 and get 1.57. Pi is the same as 3.14, and then 3 pi over 2 would be the same as 4.71. So you could convert those all to decimals and then just kind of see where does 5.8 kind of fall within that. And so 5.8 would fall between 4.71 and 6.28. So ultimately we're looking for that little acute angle right there. And all we would have to do is take that 6.28 minus the 5.8. Basically we're just taking the bigger number minus the smaller number. Say however our angles kind of line up. Like even up here when we did the negative 180 minus negative 210, technically negative 180 is the larger value. Say it's the more positive value even they're both negative. So we just did bigger minus smaller. Same thing here, we're doing bigger minus smaller. 6.28 minus 5.8 gets us a difference of 0.48 radians, which again, if you want to have a radian measure without a pi in there, that is perfectly fine. Say not a big deal. Say it's not incredibly uncommon. Okay. With our third example here, C, say we're still working in radians. Now we have a pi in there though. And if we don't want to convert to degrees or we don't want to turn it into kind of a weird decimal, if we want to keep it in terms of pi, what we could do is take those kind of pi over 2, pi, 3 pi over 2, those kind of radian measures. We could try to get a common denominator with the angle that we're working with. So all I did was look at that 12 there and get all of these measures, find out what their equivalents were in terms of pi with a denominator of 12. So like pi over 2 with a denominator of 12 would be 6 pi over 12. Or pi would just be 12 pi over 12. 3 pi over 2 would be 18 pi over 12, and then all the way around would be 24 pi over 12. And so that 17 pi over 12 falls in between the 12 and the 18. So it might not be perfectly right here, but it's at least in that quadrant. And so then if we're looking for this angle right there, again, all we're going to do is take, if this is our 17 pi over 12, we're going to take kind of the bigger number minus the smaller one. So we'll just do 17 pi over 12 minus 12 pi over 12 and get a reference angle of 5 pi over 12. And again, some of you might be able to just kind of, if you can get like the adjusted labels on the coordinate graph or coordinate plane, some of you might be able to just see, okay, the difference between 12 and 17 is 5 pi, or 5, say in that case. Okay, so if you don't want to necessarily set up like this whole subtraction thing, so you don't have to, I just kind of wanted to show you like mathematically what is technically happening there. Okay. The last thing, say, that we kind of have for today, and we've got, say, actually we had a couple things here yet. So we kind of did something like this a little bit before. Say we were given one of our trig functions and a value for it. So like here, we're given that cotangent of theta is equal to -3. So I put it over 1 just so then it kind of helps me identify, okay, adjacent, opposite, which sides are which, and it'll help me kind of label a triangle here. But we were just given this part here, and then we were given a constraint kind of related to cosine. So we know cosine is a positive value for this angle. Because there's a couple kind of scenarios where we might have like a cotangent being -3, but then cosine might be a positive value, or it might be a negative value, say depending on kind of where you're at on the unit circle. So one kind of thing here, and this is the part on the left, this is something that some people kind of remember to help them keep straight when different trig values are positive versus negative. So in quadrant 1, sine, cosine, tangent are all positive values. In quadrant 2, sine is positive, cosine is negative, tangent is negative. So here we just say sine is positive. In quadrant 3, sine is negative, cosine is negative, tangent is positive. And then in the last one, sine is negative, cosine is positive, tangent is negative. So all students take calculus is just kind of a mnemonic device or kind of something to help people remember, okay, in which quadrant is which trig function positive or negative. More specifically, which ones are positive. So in quadrant 1, they're all positive. Quadrant 2, student starts with S, sine starts with S, so sine is the one that's positive. Take starts with a T, so in quadrant 3, tangent is positive, and the calculus starts with a C, so cosine is the positive one. Okay, long story short, or kind of how that's going to relate to our problem here, okay, if we're given cotangent is a negative, say cotangent kind of follows the same sign values as, or kind of positive, negative sign values as tangent. Okay, just like cosecant will follow sine, secant will follow cosine, and stuff like that. And so I've got a little kind of mistake here that's not going to change too much here. So if we're given cotangent is equal to -3, if cotangent is a negative value, well, I know tangent is negative in quadrants 4 and 2. So I know cotangent would have to be negative in those same quadrants. So this little thing here should actually be up in quadrant 2. Okay, so I know this angle either has to be in quadrant 4 or quadrant 2. Now, this kind of condition here of cosine being a positive, that tells me which one it is. Because in quadrant 2 up here, cosine is a negative, but that's not what we want. So I know it's not this one, so that one's out, and I know it's got to be the one here in quadrant 4. Okay, because that's the one where tangent and cotangent are negative and cosine is a positive. And then once we've got that, then we can actually kind of label our sides that, okay, our cotangent is adjacent over opposite, so that means our adjacent has to be the 3, our opposite has to be the 1, because we're talking this angle right here. Now, if you're looking at that, like, well, up here we have that the adjacent is the -3, so why isn't it negative on the triangle? Well, the positive, negative kind of labels within a triangle follow kind of the same rules as like ordered pairs or points on a coordinate plane. So since this side of the triangle is taking me to the right, that should be a positive value. And then since this side of the triangle is going down, that should be a negative value. And now I still, if I did cotangent as adjacent over opposite, I'm still going to get a cotangent value of -3. So I can still kind of satisfy that condition that we were given by having a -1 and a +3. Okay, so if we clean that up a little bit. Okay, and then once we have that, then we can use our Pythagorean theorem. Say we can find that third side, so in this case it ends up being the square root of 10. I don't think I listed that Pythagorean theorem anywhere at this point. So I'm hoping that's kind of hopefully getting closer to second nature for us if it's not at this point. But then once we have that third side, then it's just sine is opposite over hypotenuse, so we got that -1 over root 10. Saying rationalize, same thing with cosine. And then tangent is, again, our cotangent value flipped. So that -3 over 1 would just turn into -1 over 3. Okay. And that's all they wanted. In this case, they just wanted the 3, the sine, cosine, tangent values. Okay. So the weird part kind of is that extra condition of, okay, what do we need here? So like which quadrant are we specifically working in this scenario? So we look at something very similar. So we've got tangent is equal to a -15 over 8, and then we're given that sine is less than 0, so that means sine is negative. And again, I have a little kind of mistake. I must have looked at that. Let's say all students take calculus thing a little bit too quickly. Because again, tangent is negative in quadrants 4 and quadrant 2, so that one should have been up there. Again, it's not going to change really much of anything because in quadrant 2, sine is positive, which again, we want sine to be negative, so we know it's not that angle. So again, we're working in quadrant 4, and again, we can label tangent is opposite over adjacent, and so our opposite side would be our -15, our adjacent would be 8. Nice part in this case, our Pythagorean theorem gives us a nice whole number of 17 for that hypotenuse side, and then from there we can kind of again, fill in our formulas, so to speak, with sine, cosine, tangent, opposite, adjacent, hypotenuse, all those different things. And so we get negative 15 over 17, 8 over 17, and then tangent was the one they gave us, but I just listed it again as the negative 15 over 8. Okay. So then, I know we kind of did some things like this a little bit earlier in a lesson. Say with cotangent of 1.35, we're just trying to use our calculator to kind of evaluate these things. And it says round to 4 decimal places. Again, I just wanted to mention with the cotangent, the secant, the cosecant, again, those you're going to have to be maybe a little bit more careful with plugging in, because like cotangent is equal to 1 over tangent. So you'd want to type in 1 divided by tangent of 1.35. And that should get us 0.2245. Okay? Or like example B, secant of negative 225, we'd want to go 1 over cosine of negative 225. And that should then get us negative 1.4142. Okay, so just be careful with the calculator stuff. Don't be afraid to throw in an extra set of parentheses if you think you need it. So it's never a bad thing to have an extra set of parentheses there. But then our last piece here, okay, it's kind of a little bit of a weird thing. And this is where I was kind of saying, like, your calculator might not be actually lying to you, but it's not giving you the full story. Okay, so we're going to use a calculator to approximate two values of theta between 0 and 360 that satisfy the equation. Round your answer to 2 decimal places. Okay, if you were to plug in to your calculator, say sine or inverse sine, so because if we do the inverse sine on both sides, we're going to get our actual angle. So if we do the inverse sine of 0.8191, so we get 54.9948 if you're in degree mode. Okay, if you're in radians, you're going to get something different. But since it said 0 to 360, I just kind of assumed degrees, and so I rounded the 54.99 to 55 degrees. But now what the calculator is technically giving you there is actually a reference angle. Okay? And so we're going to take that information and we're going to take that, combine it with that all students take calculus thing, and this is going to allow us to find two angles that actually satisfy this equation, because usually there's going to be two. Okay, your calculator is just most likely going to default to either the one in quadrant 1, so the one between 0 and 90, or the one maybe between 0 and 180 when maybe there's another one that's bigger than 180. So if we have in quadrant 1, all of them are positive. In quadrant 2, sine is positive. Quadrant 3, tangent is positive, and then cosine is positive in quadrant 4. If we know, in this case, that sine is equal to a positive number, well, there are two quadrants where sine is positive. It's quadrant 1 and quadrant 2. So if we draw just two angles, here and here, to represent those two angles wherever they are, that gives us a sine equal to a positive value. Well, that gives us kind of two reference angles here. It gives us this one that our calculator would normally default to giving us, okay, which that will be one of our answers. Say that will be one of our answers for theta. But then we also have this one here that's going to let us find a second one. Okay? And so if all the way through would be 180 degrees, well, I'm ultimately looking for what is this angle here. Okay, so to get that, we could end up taking 180 minus that 55 degrees, and that should get us 125, along with that 55 degrees that your calculator is going to kind of default giving you. Okay. And so, like I said, if you were to kind of take your calculator and type in sine of 55, so you're going to get the 0.89 or 8191. But if you also type in sine of 125, you're going to get the exact same thing. Okay, so there's usually two values or two angles that'll give you a sine or a cosine or a tangent value. Okay, your calculator is going to give you the smaller one most of the time. Okay, but we want to take that information along with, say, what we know about this piece here to be able to find that second one that our calculator is not actually giving us. Okay, so if we kind of do something really kind of similar here, so use a calculator to approximate two values of theta. Now here it says between 0 and 2 pi, say to satisfy the equation. I know it says 0 to 2 pi, okay, just for like ease of calculation and maybe for our own like comprehension to at least start with. I'm going to end up working with this thing in degrees just to make it a little bit easier for us. But we're given, in this case, that secant of theta is equal to negative 2.6667. Okay, I'm guessing it's negative 2 2/3. So we just rounded it at some point. Well, secant is 1 over cosine. So cosine should be 1 over that value. Because like if we were to put this over 1, we could flip it and get our cosine value. And I'm doing that because that's going to allow me to kind of plug in something to my calculator with cosine. Now the weird part, and this works for any trig function that you're dealing with, sine, cosine, tangent, secant, cotangent. If you're given a negative value, so like here we're given secant is equal to negative 2.6667. When we plug this in, okay, when we do the inverse cosine on both sides here, when I type that in, I'm going to type in 1 over the positive value. So if you're given a negative, don't plug that in when you actually like plug that into your calculator. Okay, what that's going to do is it's going to get the calculator to give you that reference angle of value. Okay, versus giving you something that won't actually allow us to find our second value. Okay, so don't plug in the negative there, plug in a positive, and it's going to spit out something that we can round to 68 degrees. Okay, I think it was like 68.0 something. So I can double check here. Let's go some 1 divided by 2. 67.97. So close enough to 68 degrees. So we can call it 68. Excuse me. Okay. Now again, cosine, or we were given secant is equal to a negative. Well, secant is going to be positive or negative in the same quadrants that cosine is. And cosine is negative in quadrants 2 and 3. So now we do care about the negative part of this. Okay, so I know there's going to be some angle in 2 and 3, quadrant 2, quadrant 3. That's going to make this true. And now the value that my calculator is going to spit out is going to be the measure here and the measure here. So that 68 degrees that we just got, say I can put in there, which is going to allow me to find the two angles that I want. Okay, and again, if we're saying that this is 180 here, well, one of them I can get with 180 minus 68, so I can get that 112. And then I can get the other one with 180 plus 68, and that should get me 248, say for my two different angles. Okay. Okay. So and then kind of the last one here, say a very, very similar thing. So just dealing kind of with another one of cosine. If you did not want to convert into degrees, okay, so here we're given cosine sub theta is negative 0.2541. Say if you kept your calculator in radian mode, say in this case it would give you 1.31, and again this is radians. we can do kind of the same thing. But like I had mentioned maybe in a previous lesson, if we're dealing with radians that don't have a pi involved, so just this like 1.31 kind of decimal value, what might be more beneficial is labeling our like coordinate plane instead of as like pi over 2, pi, 3 pi over 2, and 2 pi, labeling them as 1.57, the decimal value, or 3.14, 4.71, say those things. Because then it's maybe a little bit easier to kind of see where, say our, or not see where our angles lie, but to be able to like subtract to find, say, these actual angle values. Okay, and again, we were given an original, say, cosine value of negative 0.2541. So cosine is negative in quadrants 2 and 3, so that's how I know it's somewhere here or here. And again, when I plug that in, I plugged in the positive 2.541. Okay, I didn't plug in the negative to get that reference angle value, which is going to be key for us. But then that 1.31 is this part here and this part here, which just like in the last one, we did 180 minus a value and we did 180 plus a value. Well, here, since we're in radians and we've got 3.14, we'll just do 3.14 minus 1.31 and get 1.83. Say we'll do 3.14 plus 1.31 and we'll get 4.45 as our two values. Okay. So if it would be helpful to maybe add that like all students take calculus thing to your unit circle handout or something like that, absolutely go for it. So whatever helps you there, or if that just has started to kind of click or kind of make sense for you, awesome. But as far as our assignment goes, so this is going to be the last one out of the book for a little bit. Say we got some worksheets kind of for the next couple here. But there's kind of our assignment that goes with this. Like always, if there's anything that I went through too quickly or that just isn't making sense